Hi, this is Josh Tabor, one of the co-authors of Statistical Reasoning in Sports. In this video, I'd like to give you an introduction to SRAS 2E. If you're looking at the bobbleheads, I'm the one on the left. My co-author Chris Franklin is in the middle, and Doug Tyson, who headed up all the teachers' resource materials, is on the right. As in many sports, having a good team is the key to putting out a good product, and we've got an excellent team working on this edition of SRAS. I want to start by talking about the big picture. Statistical Reasoning in Sports is a textbook that introduces the principles of statistical reasoning using a student-friendly approach that emphasizes the entire statistical process, all in a motivating sports context. Each of those four bolded phrases are important, and we'll be talking about them later on in this video. In short, Statistical Reasoning in Sports is a unique and powerful way to learn about statistics. SRAS is aligned well with many state standards. However, it's not designed for AP statistics. If you're interested in an AP statistics book, strongly recommend you check out The Practice of Statistics. Now I want to talk a little bit about how SRAS is different than a traditional statistics book, and in our opinion, how it's better. First, most of the examples and exercises come from the world of sports, where we use real data to investigate topics that are discussed in the media, on the internet, and in stadiums everywhere. Is there a home field advantage in the NFL? Is it possible for a basketball player to get the hot hand? Do high-tech swimsuits really make you faster? And when should a football team go for it on fourth down? Using sports as a context is motivating to lots and lots of students, and it's really obvious how this math that students are learning is applied in the real world. We begin each chapter with a motivating statistical question, much like the questions you saw on the previous slide, and then answer that question using the four-component process recommended by the American Statistical Association's GAZE document. GAZE stands for the Guidelines for Assessment and Instruction in Statistics Education. The process is formulate questions, then collect data, analyze the data, and finally interpret the results or make conclusions. SRAS is designed so that important skills are added as needed so that students can understand immediately how that skill is used. No skill is introduced until it's important for answering the question of interest in that particular chapter. Chapters are organized so that new chapters build on the skills and concepts introduced in previous chapters. SRAS is also different in that we use simulation-based inference rather than traditional inference methods, such as t-tests or z-tests. This allows students to carry out all four steps of the statistical process from the very beginning of the course, rather than having to wait until the end of the book to complete the process. In most traditional statistics books, there are several chapters introducing basic skills about calculating summary statistics and making graphs. Then there's some chapters on probability, finally, sampling distributions, and then traditional inference methods. So students may be able to ask questions early in the year and maybe do some data analysis, but they're unable to draw conclusions until the very end. That can be pretty unsatisfying. The way SRAS is designed, students can ask a question and then carry through the entire process in that chapter. This is because we use simulation-based inference. We don't need to build up lots of theory and probability distributions. All students need are hands-on spinners, shuffling cards, and other things. Then, once students understand how the simulations work, we follow up with technology. This allows students to focus on conceptual understanding and statistical thinking rather than memorizing a set of formulas. In fact, students using SRAS learn a lot of statistics, but they don't even realize it because the hands-on simulation process so naturally fits the questions that we ask. Another way that SRAS is different is it encourages students to be active in class, both with the hands-on simulation that we talked about, but also active data collection in the field, the gym, the court, etc. There's lots of examples of student-collected data and suggestions for ways that you could collect data with your class. One thing that's great about teaching this course is it allows students to do things that they wouldn't ordinarily be able to do in a math class, and that gets kids excited and happy to be in your course. Also, at the end of each chapter, there's an investigative project that allows students to put it all together and research their favorite teams and athletes. Essentially what students will be doing is recreating one of the longer examples in the chapter, or imitating the question of interest in that chapter, but applying it to their own favorite athlete or team. It also allows students to provide an assessment that is not high-stakes tests. It allows them to show off what they know about the entire statistical process. Now, let's take a quick tour of SRIS. You'll see an example of a typical page here on the screen. At the top, you can see that each chapter is divided into sections, with each chapter having 4 or 5 sections. Also, each section has its own set of exercises. This makes it easy for students who get stuck on an exercise to look back into the book to help find an answer. It also helps teachers know which problems to assign for homework. On the left side of the page, you'll see examples of several different types of boxes. Sports terms boxes and key terms boxes are in the margin and define important terms as they're needed. Don't worry about becoming a sports expert before you teach this class, or making sure that your kids are sports experts before they take it. There's really only 2 things that students and teachers need to know about sports. 1, it's better to win than lose, and 2, to win, you need to score more points or goals or runs than the other team. Also on this page, you can see a review box. Because of the way SRIS is structured, chapters build on each other. As a consequence, it's important to review things from previous chapters so students can build on their knowledge. On this page, you'll see an example. Examples come from a variety of sports and are always written in what we call problem-solution format to mimic exercises. So in this case, you'll see an introduction, then a problem. Notice that the solution is written in a different font. We call it the student font. This is to provide the students a model response that they can imitate in their homework. It's really helpful for students to look back at these examples to know exactly how their homework should be done. You'll also see on this page a Stats 101 feature. This shows how the same concepts are presented in a traditional course. This is helpful for students who will go on to take another statistics course in their future. Now you see a page showing some different exercises. Key exercises, like number 17 at the top, are linked back to an example in the text. So you'll see a page number reference. That's again to help students, if they get stuck on this question, it points them in the right direction where they can find some help. Also, occasional exercises have a video with an SRIS teacher explaining how to do this question. Those video exercises are marked with the play button. Also notice that exercises are paired, so that teachers have the option to assign an odd-numbered item that has an answer in the back of the book, or an even-numbered item. In each pair, the questions are essentially the same, but the context is different. You can see in exercise 17, we have an example about a female golfer, and in question 18, about a baseball player. In SRIS, we have specially designed applets that can be graphing calculator replacements and make simulation easy. So if your students don't already have graphing calculators, but they do have devices such as iPads or Chromebooks or even just smartphones, students can use these applets to do everything a graphing calculator can do and lots more. In fact, even if students have graphing calculators, they're going to want to use these applets because they're so great for doing data analysis, normal distribution and probability calculations, and simulation-based inference. Throughout the book, you'll find tech corners that show students how to use technology, both the applets and graphing calculators, to make graphs, calculate summary statistics, and perform simulations. Videos are also available for the tech corners on the student site. In every chapter of SRIS, there's a dedicated section for other applications, that is, non-sports applications, including enough exercises for 2 homework assignments. These sections are here for teachers or students who want to learn how these same concepts can be applied in contexts outside of sports. The examples and the exercises closely mimic previous sections, so students can easily see the connections to the applications outside of sports. At the end of each chapter, we have a number of features, including a chapter summary that reviews key ideas, a What Did You Learn grid that provides learning targets that can be used as a checklist for students as they prepare for the chapter test. These learning targets also include references to the section number, an example, including a page number, that assesses that learning target, and chapter review exercises where they can practice to make sure that they can do that learning target. There's also a set of chapter review exercises at the end of every chapter, including all answers to the chapter review exercises in the back of the book. Now, I'd like to briefly talk about the teacher's resource materials that are included with SRAS. Of course, there's a full solutions manual that includes detailed solutions to the odd-numbered, even-numbered, and chapter review exercises. Every chapter comes with a chapter overview, as well as page-by-page advice for teachers. The chapter overview shows you how a particular chapter fits with the chapters before it and the chapters that are to come. The page-by-page advice for teachers will be very helpful as you teach this course. For example, it might say, on page 35, make sure and point out this common error that students make. Or on page 42, make sure to comment about this particular thing at the end of the example. There's also great advice for how to conduct the hands-on simulations that we recommend doing throughout the course. Every example in SRAS includes an alternate example that asks the same basic questions, but in a different context. These alternate examples are in Word format so that you can easily import them into PowerPoint, a handout, or an assessment. Every chapter comes with 2 sample tests with answers keys. There are rubrics for each of the investigative projects that come at the end of the chapter. You can use these rubrics as is, or you can modify them for your own purposes. And finally, there's pacing guides, both for a full year course as well as a 1-semester course. Now, as we're wrapping up, I'd like to thank you for your interest in statistical reasoning in sports. Obviously, we think it's a great book, and we hope that you and your students enjoy using it. If you have questions, please email your BFW rep. You can find your rep at that website, or go ahead and email me directly at taborstats@gmail.com, or Doug if you have questions about the teacher's resource materials at tyson.doug@gmail.com. Again, thanks for your interest in statistical reasoning in sports.